Hey people, what's going on? This is Rahul SriRam and welcome to the Skinny Coder YouTube channel. So in this video, we'll be discussing about Java math class and the BigInteger and BigDecimal classes too. So this video is very important for competitive programmers and this is not specifically made for them, but it would be of great help to them. Okay, so let me dive in. I'm using intellij-idea for as my Java integrated development environment. You can pretty much use anything. By the way, I'm on Linux OS. You can use any operating system of your choice. It doesn't matter. So you should, I think the prerequisite is you should know how to compile and run a Java program, and you should have Java and the JDK installed on your system. So that is the basic requirement. So let me get into the overview of this video. Just give me a minute. Yeah. So firstly, we'll be talking about the math class, and there are some precision methods like floor and ceiling and round methods in there. And then I'll also introduce you to pi and exponent constants in the math class. Then we'll dive into logarithmic and exponential methods, like two different bases and how can we access them simply and all. Then we'll go to power and root methods like square root, cube root, and power methods and all. Then we'll get into the sign related methods like the absolute value, which is a modulus function, and then the signum function and all those kind of, and the copy sign. And copy sign is a really useful method at times. And we'll also discuss about the trigonometric methods. So we have the sine, cosine, and sine inverse, cos inverse, and tan, and there are like two types of tan inverse functions, and I'll be introducing you both the tan inverse functions. We also have the directly finding the hypotenuse method using the base and the height, so that is pretty cool too. We can convert between radians and degrees to radians. That is also possible, and I'll be introducing them in the trigonometric section. And there are also other functions like maximum of two numbers, minimum, and generating a random number, all these combinations. So the second part of the video will be the BigInteger and BigDecimal classes, which are used to store large input values or the large floating point numbers and fixed point numbers. So the highest data type in Java that can store values is long, like we know byte is the shortest of one, then comes short, then comes int, and the maximum is long. And if you want to store data that is having more number of digits or more number of fixed point decimals, more than floats and doubles or more than long, then we get into BigInteger and BigDecimal classes. So these are really useful while solving problems on competitive programming uh, online judges. So because most of the problems will be having huge data sets or many test cases which may have the input numbers in wide ranges, so it would be very tough to and very tardy in programming languages like C++, which has not got this feature like BigDecimal and BigInteger. So this is one of the very cool features of Java language. Python too accepts. I think there is no upper limit for the maximum overflow of integers or numbers in Python. But in Java there is a range, and a big integer you can take up to like 40 to 50 digits too. So in them again, the problem with BigInteger and BigDecimal classes is we cannot use operators in them. Okay, like we can't add to big integer objects, or we cannot subtract them, or we cannot do that logical operators and compare them. So for that we have another methods inbuilt. The arithmetic operation should be performed by methods, the math related methods and the logical operations. So these will cover the basics of big integer and BigDecimal classes. And then comes GCD and Primes, which is the most important part of big integer and BigDecimal classes. Like they have got inbuilt methods for GCD and finding primes. We don't need to write a function for primes and finding the next prime number. All these are inbuilt there in Java, so we can directly use them in our code. And we'll also solve a problem on Project Euler. Project Euler is a competitive programming, not specifically competitive programming site, but it's a archive site which is having many programming challenges in there. So it is completely math related. If you're a math geek and if you want to solve math related questions, which are including big integer kind of large numbers and huge input data types, then I think Project Euler is the best site. It'll improve your logic too much. Like it will give a very good knowledge over a language and the ranges of their values of the data types and all of them. So let's not waste time and let's dive in. Okay, so let me open intellij-idea. Okay, so first let me get into the flow demo class. Okay, so this is how we import in Java, right? I assume you know how basic concepts like static methods and importing inbuilt classes in Java. So importing inbuilt classes is nothing but even for input output, many people write import.java.io.star, or for scanner they write util.scanner. So I think that is a very basic of learning Java. So I'm not going to explain all of those. So we'll be importing the math class, and the most important thing to notice is in math class all the methods. By the way, we call methods because those are functions which are related to a class. So functions which are not related to a class are known as plain functions. In Java, there won't be any plain functions because every function in Java should be wrapped inside a class. So there can be only static methods which are related to the class itself, or non-static members which are also which are related to the objects that are created upon using that class or the instances of the class. So every method in Java in Java.math in the math class in Java is a static method. Like you can't operate them using the objects of the math class because you don't create objects using the math class. You just have static methods in them. You cannot create objects using the math class. You can use the static methods in math class, and we can send in our primitive data types or even the objects to get our desired output. For example, let's get the first thing we'll be discussing about, as I've told you, the floating point precision related methods. At times we'll be having floating points as inputs like 8.2, 9.7 and those kind of. So you want to find the ceiling function of them. Ceiling function is similar to the least integer function in mathematics. Like it will give the greatest integer, it will give the least integer that is greater than the input number. So the least integer that is greater than 8.2 is 9. And if you go to minus numbers too, it is pretty simple there, because you shouldn't see the magnitude over there. It won't be 3 because minus 3 is lesser than minus 2.3 obviously. So it will be minus 2. Okay, so this is the ceil function, and the quite opposite of this is the floor function. This is the GIF function which is the greatest integer function in plain mathematics. I think people who have prepared for competitive examinations like IITJ and all, how screwed up the GIF function made us, and signum functions and all of those. We have inbuilt methods in Java for all of them. I'll be discussing them. Okay, so ceil and floor will be using these mainly in problems which are having huge data sets in big data and all of them. We'll have to clean the data which is given to us, and at times, not every time, at times we want to make them all integers even though they are given as strings or floating point decimal numbers. Then we'll want to change them into plain integers. So that is when we'll be using ceil and floor methods. Okay, so and then we have round is like a clone of these both. Okay, so what this will be doing is it will have a bar like 0.5 or 0.005 or 0.05. These are bars in the round method. If a number is more than that 0.5 or 0.005 or the half of the decimal point, it will behave like a ceil function. If the floating point, if the decimal point is lesser than that half of the, pretty much like, for example, we are having 8.2 and the nearest integer to it is 8 and not 9. But when we go to 9.7, the nearest integer to it is 10 but not 8. Okay, like here it will behave like a ceil function, and here it will be behaving like a floor function. Even with the negative numbers, minus 2.3, the nearest integer to this is minus 2, and for minus 4.8, since it is lesser than minus since it is lesser than minus 4.5, it will go to minus 5, and here it is behaving as floor function, and here it is behaving like a ceil function. Okay, so let me run these if you doubt me. I hope you not. but that's fine. I'll comment these, and I'm running it. By the way, if you're not using an integrated development environment like I am doing so, then I think you'll have to compile the code using javac and the class name.class command, and to run it you'll have to use java space the plain class name, and that will run your code and that will compile, and if there are any errors or warnings, they'll be shown to you in the console. But since I'm using an IDE like intellij-idea, or you can also use Eclipse, NetBeans, whatever you use, or you can also write plain code in Notepad, or okay, who writes code in Notepad? I don't think anyone will be doing it now. I hope you're not. Okay, so yeah, let's get into the point. The ceil function 8.2 is giving 9, 10, and -2 and -4. Pretty cool. Okay, now let me comment this, and here we'll do with the floor. I'm compiling and running it at the same time with the same command, keyboard shortcut. So yeah, 8 is the floor of 8.2, 9, and -3 is the least number that is lesser than -2.3, and -5 is the least number that is the greatest number that is lesser than -4.8. Okay, yeah, so let me comment this and get there. This one round, and let me run this. Okay, the first two numbers, since they are positive, and the two okay, not the let me not put it that way. Since this is lesser than 8.5, and 8.5 is the the middle point of 8 and 9, it will go to 8. Okay, and if it is greater than 8.5, like it is 8.7, imagine it to be 8.7, which is greater than 8 and almost equal to 9, so it will come out as 9, the first one. Okay, and this is not only for the first decimal place. If, for example, if you're having 8.76, which is greater than 8.75, and if I run this, I'll still get 9. Okay, because it is greater than 8.50. okay, yeah, so that is how it works. And -2.3 is also like nearer to -2 and not -3, because the decimal points between -2 and -3 is 0.3, and the points between 2.3 and 3 is 0.7, so 3 beats it and we get to -2. Okay, cool. Now we have some constants in math class, like the pi and e. You see this pi gives us the result of what we know, that the normal pi. It will be it will be 3.14. See that number, 3.1415926, some number. And e is also like the exponent constant that we use in our exponential functions and all, which is closely related to the logarithmic functions. So it is 2.718. We can also print those to the console if you want. Okay, see those are the numbers. Okay, cool. So I think we are done with this float demo thing. So okay, now we are done with the precision methods. Now let's get into logarithmic and exponent methods. There are only 3 functions in logarithmic and exponent functions. Okay, so the first thing is log, which will give us a natural logarithm. By natural logarithm, I think you know this. Natural logarithms will be having a base of e, which we have just seen in the other class. Okay, math.e. E is the exponent constant. They'll be having a base of e, and this function, which is analogous to this, which is similar to this, but will be having log 10 in the function name, will be having a base of 10. Okay, so for example, let me run this. So let me comment out these both first. Just to this, yeah, I'm running this. Yeah, so the first one, obviously this is the base of e, and if you're finding ln e, by the way, ln is also known as the natural logarithm, or you can also say log e to the base e, and that will be 1. And obviously anything having a 0 in its, if you know the graph of logarithms, then you'll be having a -infinity. It will be approaching a -infinity. And anything, be it any base, like even the log 10 or log e, the natural logarithm, or this logarithm too, they'll be having, if we are finding the log of 1, then that will be 0, right? That is, I assume that you all know about that. let me comment that. And it is the same, like math dot log 10 is also the same. There is no difference except that it will be having a base of 10 instead of e, because these both are the most common logarithms that we use, right? Base e and base 10 logarithms are the most basic and simple logarithms that we'll be using. Okay, so 10 square is 100, so we'll be getting a 2 here, and 10 power 1 is 10, so we'll be getting a 1 here, and 10 power 0.1 is 1, so we'll be getting a 0.1 here. So you know what I'm talking about if you know logarithms, right? So let me comment those and get into the exponent function. Exponent function is like, it's a power function. You'll be getting into power functions when we get into power and roots. I should have included it in that, but I tried to include logarithmic and exponential functions because they are pretty similar. Exponent function does nothing. It will take the base as e, and the parameter that we are passing it into will be the exponent of the e. So anything power 0 will be 1, that is sure, and e power 1 will obviously return math dot e, like the constant that you see. So they have written there the above is equal to math dot e, and e power 0.5 or root e, these values is this, so we can find them too, like this. See that this is math dot e, and anything power 0 is 1, and this is the root e value. You can do whatever calculation you want to using these methods. Okay, so now that we are done with this, what is also remaining? We are going to power and root methods. Okay, this is a quick video. I'll be showing you all the available methods and deeply dive into BigInteger and BigDecimal classes quickly. Okay, so the square root function directly takes in a parameter and it returns the square root of that number. Obviously, a negative number won't be having a square root. The problem is they will be having a square root, but they will be complex numbers or imaginary numbers. The square root of this is 6i, and to include imaginary numbers in our Java programs, we have a special class like complex, and this tutorial is not about it. So obviously, println functions only print strings, or the basic primitive data types that are available in the math in the Java programming language by default, without importing complex and all. So obviously it will be returning not a number. Nan is also a kind of a constant or notation that we'll be using when we are not printing to the console, or we are not printing numbers to the console. Nan also refers to strings at times because strings aren't numbers, and booleans too, booleans aren't numbers too. Okay, so this is a complex number, so it is not a number, because what all are not a numbers are just short, byte, int, float, double, and long. Okay, and big integer. I think so. I will have to check. We'll go through it. Okay, we'll see if that doesn't come under a nan or that does come under a nan. Okay, so the square root of 2 is 1.414. This is a very famous constant that you might have been knowing. So similar to, we are having a cube root function too. This method is not available in many programming languages. We'll have to write our own cube root functions, and which is such a pain in the ass. So I think this is a really good method if at all you want to find cube roots, and when you're dealing with complex numbers, you'll be having cube roots of one kind of things, right? I remember. So we should have cube roots here, and obviously even cube roots are having minus numbers as the parameters. That doesn't matter because minus 2 power 3 is minus 8. So cube root, perfect cubes here, perfect squares might not be negative numbers, but perfect cubes can be negative numbers. So this is simple math, and the cube root of 45 is this some number, I don't know, like it must be that number because Java is telling me, and we should trust the computer more than we trust ourselves. Let me run those both methods at a time. So yeah, negative number, we are getting an nan, and square root of 9 is 3, and square root of 3 is that pretty famous constant, and 27's cube root is 3, and negative number's cube root is 2 because minus 8 is given, and yeah, pretty sure. Now let me comment this both and introduce you to the power method. These are inbuilt methods, okay, right? They're pretty quick. You can use them in your competitive programming solutions. You don't need to write root function in separately, or you don't need to write a loop to have a power over there, or you don't have any operators too, like Python, which will be having a double asterisk operator. X asterisk asterisk y will do x power y directly. Okay, similar to JavaScript too, but in Java I don't know if such operator is present. Okay, so let me run this. So what does this power method do? It will be taking two parameters. The first parameter is the base and the second parameter is the exponent. Okay, so base power exponent will be returned to us. 2 power 3 is 8 and anything power 0 is 1, so 3 power 0 is 1 is returned. Okay, and we can also do the square root method. Instead of writing the square root method, we can also do it in the power method. We can pass in a parameter like 0.5 which will be acting as a root. Okay, so square root of 4 or 4 power half is 2 again. Okay, so yeah, we're done with power and root methods too. Now let's get into sign methods. This is the most important part because sign methods can be pretty annoying at times. You want a single sign in your program will make all the test cases go in vain. Like you write a program, it will be returning the quite opposite number that you want, and you don't know where you're going wrong. You'll be just trying to add a unary minus or unary plus operators, and I hope that that won't work that way. You'll have to use the sign methods. Okay, so what is the absolute method? Absolute is like a modulus function. Okay, so in mathematics we're having a modulus function, like we pass anything to that function and it will return the positive form of it, right? And if you return positive numbers, it will just return the number itself. So if you pass a positive number, I'm passing a 50, positive 50, and it is returning me 50. Negative 50, it will still return me a positive 50, and this will be applicable to floating point numbers like floats and doubles too. I send a negative or positive number, it will return the modulus of that number. Okay, so signum function, again I've been talking about this when I was talking about IIT and people who are from there. The GIF function, the signum function, the step up and step down functions, I think they used to be pretty interesting while I was doing math. So when I found out there are inbuilt methods in Java programming language for these, I felt like, wow, I hope I was allowed to use Java in my entrance examinations. Okay, so I'm having signum here. What does signum do? It will take a number. If it is positive, it will return a positive 1. If it is negative, it will return a -1. And if it is 0, it will return a 0. And I think there will be a -0 too. Let's check it out. Okay, so let me run those two first. Okay, the absolute is returning all positive numbers, even though we are passing negative numbers to it. And yeah, so positive number 1, negative number -1, and 0 is returning a 0. What about a negative 0? You might be thinking, what is a negative 0? Does it even exist? As far as I know, in programming languages like JavaScript, those do exist. Okay, but in Java, let me check it out. I don't know. Yeah, even if it's a negative 0, it is just giving me a 0 as the output, because in magnitude it is a 0. Okay, so if the first priority to this function is the magnitude and then comes the sign, if the magnitude is non-zero, then it will check the sign. If it is 0, it will return a 0. Okay, cool. So what is a copy sign method? This is what I was talking about when I just opened this class, sign methods, because copy sign can be very useful in programming contests. Basically, you'll be having you want to negate the number or give the negative of that number, and you can't just use strings directly. Okay, by the way, for example, you're having a function. Let me demonstrate it. You're having static int return func, which will be returning a function. Okay, it will take a parameter as integer and it will return -x. This can be pretty misleading at times. Okay, like to just return a -x, this can be really misleading at times. It'll if you're sending a minus number, it will return a positive number, and if you don't want that, you'll have to write an if condition here. And to check the sign of that number, you'll have to use the greater than 0 or less than 0 operators, and it is quite a code to do all that, right? It will take like 4 to 5 lines and an extra overhead of a function, right? You'll have to write another function of this sort, and you don't want to just use unary operators that way. Okay, unary operators are primarily used for type conversions. Basically, like nobody know that we can use unary operators for type conversions, but that is a pretty cool way to do type conversions. But while doing this sign manipulation, sign related methods, I think copy sign, math.copy sign is the best. Okay, what this method does is it will take the first parameter and it will return the same thing with the magnitude of the first parameter and the sign of the second parameter. Okay, so the sign of the second parameter is negative, so it will return minus 50 because magnitude of the first parameter is 50. The sign of the first parameter is plus and the magnitude of the first parameter is 50, so it will return a plus 50. People get confused over here. They think these get multiplied, or the signs of these get multiplied with the first parameter and they send it. They think that minus into plus 50 is minus 50 and plus into minus 50 is minus 50. No, that doesn't happen that way. Whatever you send in the first parameter, only the magnitude of that will be taken, like the modulus of that will be taken, and whatever you're doing in the second parameter, only the sign of that will be taken. So copy sign function is a mix of these both, right? Absolute function will be applied on the first parameter and signum function will be applied on the second parameter, and those both will be multiplied to get our result. Okay, so this is a clone of these. If you want both of them to happen on the single number, you can directly use the copy sign method. Okay, so let me run this and show you. So you see there, first parameter 50 in magnitude, second parameter 50 in magnitude, and the third function call is having 4 in magnitude, and the minus, plus, and by the way 0. I know this is pretty weird because I told you here the first priority in a signum function will be the magnitude. If the magnitude is 0, then it won't check the sign. If it isn't 0, then it will go to sign. If the sign is negative, it will return minus 1. If the sign is positive, it will return plus 1. Okay, and here it is checking the magnitude. It is a 0, so it will by default stick to plus. Okay, there is nothing like a negative 0 in Java programming language. In JavaScript, that do exist, and there is a really big, like trust me, a really big series coming on JavaScript. Like it will be around 11 to 12 hours in total. It will be a complete JavaScript developer bootcamp. So I hope you're interested to learn JavaScript. Okay, so let me get into the next thing. I hate these trigonometric methods. Like, if at all you're solving problems like convex hull or geometrical related competitive programming problems, in contests, most of the cases, like contest will be having 6 to 7 or at times a maximum of 9 to 10 programming problems given to you. So you'll have to solve them using your skills, and at least 20% of at least 10% or at most 20% of the problems will be having geometry related things like convex hull or area and polygons and whatever. Too much of high level geometry, mathematics and trigonometry are related to solve them. And in those highly complex problems, if you don't even know how to find the sign of a number of a thing, or you don't know how to directly find the hypotenuse, and you still are using the square root, and in that square root you are using the power of this and power of this, and you add them both, that is pretty long, right? You are having simple trigonometric functions, and by using these, the simple math involved in the programming will be done very easily, and you can concentrate on the complex math like finding the area given the sides. And yeah, that may sound simple, but it isn't, trust me. It gets really messy at times. Sorry for that. Okay, so let me get, these are just the sine and cos functions, and a means arc sine and arc cosine, and a tan means arc tan. By arc tan I mean sine inverse or cos inverse and tan inverse. Okay, so these take in single parameters, all these. Only the a tan 2 will take 2 parameters. I'll discuss that. So all these take 2 parameters, and we expect those parameters to be in radians. Okay, this is the most important thing. If you're trying to pass them in degrees, or it gets pretty annoying at times. So you'll have to stick to radians. Math.pi is a radian number. Obviously, it is 3.14. And pi by 2, like sine of pi by 2 will be 1. Obviously, sine 90 is 1. Sine 0 is 0. Cos 0 is 1. And cos minus pi is minus 1, right? It is I remember doing all these in my physics for components of a vector and all of this. But we'll having many vectors and direction related problems in programming related online judges like SPOJ or HackerRank or CodeChef and all. You might be introduced to problems like maze, 3D maze, or they will be given 5 points on a plane and you'll have to find the direction and the angle between them. And it is purely math class oriented functions should be enough. You can suffice the problems using the inbuilt static methods of the math class. Okay, I'm using the pi constant over here, so that's it. Let me run this and show you. Okay, so yeah, sine of pi by 2 is 1, sine 0 is 0, cos 0 is 1, and sine minus pi is minus 1, right? And similarly, you also will be knowing inverse functions of sine and cos. I think I won't be discussing them. And then we have tan. Tan is like fine, but the most important part comes with a tan 2. At times you'll be given two parameters in radians. Okay, and what does this a tan 2 do is it will return the division of this both. Okay, like this is tan inverse x by y. Okay, so tan inverse x by y will be the returning value. So what I'm sending is, I know that tan 60 is root 3, right? So what I'm doing is 3 and the math dot square root of 3. So 3 by root 3 will be root 3 in total. So tan inverse root 3 will be 60 degrees, and 60 degrees in radians, because it will be returning in radians. You shouldn't get confused. Okay, like in normal functions, we should pass radians. It will give us integers back, like the range of the function, whatever the range of the function be, it will be returning it back. And for arc functions or the inverse functions, we will be getting radians back. Okay, we won't get degrees. There is no degrees involved anywhere in here. And the most annoying part is, in competitive programming, people give you degrees, they won't give you radians. Okay, they mention degrees, that too very complex degrees, like 43.5 and 52.7 and those kind of really complex degrees, and you'll have to know how to convert them, and that is where this thing comes in. Okay, so let me first just run this and then we'll go into that. Okay, what did I do? Yeah, so tan inverse minus 1. What is tan inverse minus 1? It is 45 degrees. 45 is like pi by 4, so 3.14 you can divide it by 4 and it will be around 0.78. Okay, so, and this is the opposite of this. What I'm doing here is I'm taking a tan of pi by 4, which is around 0.999 kind of. That is known as the floating point error. This does exist in many programming languages. I think I'll be making a very short video, like 6 to 7 minutes video on the floating point error and how to overcome and what is the main reason behind them. And to avoid that error, I've rounded it. Else I won't be doing it, because you'll be returning a 0.9999, which is like 6 to 7 decimals of 9, and that isn't accurate, right? 1 is accurate, or maybe that is accurate and we were taught as 1 from childhood for simplicity. I don't know. Okay, now this is the tan function that will be taking two parameters, and it will divide these and return the inverse of that. Okay, cool. Let me comment this. And yeah, 2 radians. Simple, as the name suggests. We'll pass in degrees, radians will be given to us. We'll pass in radians and degrees will be given to us. Okay, so let me uncomment this and show you. See that? I'm passing 180 degrees, and obviously 180 degrees is like pi, we know that, so it is 3.14 and that all. And pi by 2 in degrees will be 90 degrees. Okay, that's pretty, I've included pretty simple examples, but it will be really helpful when you're using degrees and all. You can directly pass the degrees in there and you'll get it in radians. Okay, you can include that number in these functions and you'll get the cosine or sine of that angle. And as I told you, complex angles like 52.2 or something will be given, and you don't need to worry at all. And then comes a really handy function. I like this so much. many problems will be related to right angles, or at times maybe not related to right angles, and we might want to find the height of a triangle at times. Okay, so in problems related to trigonometry and geometry, there you know the result and you know one of these parameters and you want to find the other parameter, right? So that is where functions like hypot comes to the rescue. You can include these and you can find the solutions. It will get directly a root over 3 square plus 4 square. Like, it's simple, right? You don't need to do this. Like math dot square root of, and again math dot power okay 3 comma 2, which is 3 square, and I'm adding it to again a math dot power 4 comma 2, which is 4 square, and what this will be returning is the square root of 3 square plus 4 square. And instead of doing all this thing, I can directly do hypot though. So this function takes in these, and if these may form a Pythagorean triplet, it will be returning a normal number, and if it isn't, it will give a weird number like this. Okay, and most of the times you'll be getting weird numbers, at least in competitive programming. Yeah, okay, so is that 4 square plus 3 square is 5, and that's it. That's pretty much it. That is with the trigonometric functions. What else have we got? Other methods. Yeah, so what are these other methods? We have the max function. It will take in two parameters and it will return the maximum of them. Okay, in languages like C++, also there is a max and min functions. Day 2 will take two parameters and it will return the maximum of them. But if you're having multiple parameters and you want to find the maximum of them, you can pass them as initializer list using the curly braces. But in Java that isn't possible. We'll have to keep nesting it, like, let me demonstrate that to you. Comment this and run that. See that? So maximum of 50 and 100 is 100, and maximum of minus 50 and minus 30 is minus 30, because negative numbers, you should be pretty careful. And obviously maximum of minus 2 and 3 is obviously 3, because that is positive, and the quite opposite is here. Okay, now if you want to find the maximum of three numbers, then what you do is you do math dot max of 2 comma, and the other parameter you take again a math dot max 3 comma 4. Okay, so the maximum of 3 comma 4 will be first computed using the BODMAS rule, and 4 will be written, and again the maximum of 2 and 4 will be taken out, and again 4 will be written. Okay, so that is how you'll have to do it in Java, and at times this might be quite disappointing. Okay, and what about the random thing? Random is a function that doesn't take any parameters, and it will return a random number whose range is between 0 to 1. Okay, and if you want a number that is ranging between 0 to 10, you'll have to multiply each number with 10, because you'll be getting the tens multiple of the same number, right? I mean 10 multiplied by the same number. So if I run this, these won't be same every time you run them. Okay, like this will be a number, this will be another, and this will be another. And remember, this is 0.37, 0.79 and 0.05. Again, if I run it, sorry, that won't be the same. See that? 37 and all of that gone now. Right. So I think that is it with math class. So I think we'll have to get into BigInteger and BigDecimal classes. Okay. Yeah. Cool. BigInteger. For example, I'm having this playground method where I'll be introducing you to the classes, because math class is like, at times that might be common to you, because many of them might be using it in your day-to-day Java programming. But BigInteger is like, many people don't know how to use it, and I think this will be a very good introduction to it. So what if you're having 30 digits in your input number? Okay, I know, right? Like at times this is the case, and most of the times this is the case. Okay, and in those cases you want to initialize big integers. Okay, you want to use big integers, and big integers come under the math package. You shouldn't confuse this. Okay, these are having math classes, math class which is included in the lang package. Okay, and this big integer is a class included in the math package, and math is not the same here. This is a class over here, this is a package over here. Okay, yeah. So big integer, and similar to this big decimal too, the big integer is for fixed point numbers, and the decimal is for floating point numbers. Like we have byte, short, int, and long as the primitive data types, or the inbuilt classes used in Java programming language for fixed point numbers. And if the range is not sufficient for you, then you'll be using big integer. Okay, and you're having float and double for floating point numbers, like the given ones to you inbuilt by default. And if the precision or the int value is not sufficient for you, then you'll be using the big decimal class. Okay, they'll be having this pretty similar methods in them. I'll be only demonstrating big integer, and I want you to explore big decimal on the web. Okay, and solve some problems too on sites like SPOJ or mostly Project Euler, because almost every problem related to Project Euler will be having really big numbers in front. Okay, that is where and that is a really not only about big numbers, but it is also about the math logic. Project Euler is having really good problems, which are quality based problems. It will enhance your programming and mathematical skills. Okay, let's get into big integer. How do I initialize it? The pretty same way you do with any Java object. The syntax for initializing an object and instantiation of an object in Java is using the class name as the data type and the variable name. For example, I'll be taking it as begin. Okay, and I'll be using the new keyword to allocate memory, and here I'll be calling the constructor function, which will take this constructor function is an overloaded function, by the way. Okay, like this is overloaded. You can pass in a string here, and I most of the times I use strings, the string type of input for the constructor number. Okay, like I can keep on passing numbers and it doesn't matter what I'm using it will be stored. Okay, not this actually, that isn't possible. Okay, so I think you can print it to the console. Where is my main method? Let me. Okay, there's a problem maybe. No, there isn't. Let me call that function. Okay, the class name is BigInteger demo dot playground, and I compiled it, and you see that you don't see this large numbers using the long, which is the longest inbuilt data type in Java, right? See this? It is all printed to the console, and the data type of this is big integer. Okay, it is not string. You're passing it as a string, but it will be converted to a big integer. And this is pretty cool, right? But let me tell you something really depressing. Big integers doesn't support operators, right? Yeah. For simplicity, let me use simple numbers like 2, and let me copy this line and paste it in here, and let me call it 3, and let me call it big integer 1 and big integer 2. Okay, so what's wrong with it? I can't just be like big integer 1 plus big int 2. Okay, that isn't possible. You see that in there? Operator plus cannot be applied to big integers. Any operator isn't possible on big integers. And you might find some way to add, subtract, or perform logical operations or whatever be it. You found a way. But what about the math classes? I told you math methods. I told you all the methods that we have discussed till now. They are only applicable to the inbuilt data types like byte, short, float, demo, like float, double, and long and int. Okay, all these 6 data types are only supported in that, nothing else. So there you can't use big integers, right? You can't find the maximum of 2 big integers using the math.max or uh, power of a big integer, and all of those you can't do it. You can just do for at most long data type or double data type in floating numbers. That's all. So how do I perform mathematical operations that are discussed in the math class using big integers? So that is where the big integer API comes in. There are pretty cool methods inbuilt in the big integer method, in the big integer class. But unlike the Java math class, those aren't static methods. There are some static methods too, but in this tutorial we'll be sticking to the normal methods, non-static methods only. So what are the kinds of methods involved in there? Okay, the first thing are the arithmetic methods, and then we have all the arithmetic methods are used as a replacement to the arithmetic operators: plus, minus, asterisk, and like, let me be clear, to find the sum of two big integers, to find the remainder, and also to find the quotient, to find the product. Okay, so here we'll be using the arithmetic methods because we can't use operators, and similar it applies to logical operations too. You cannot apply and operator, or or operator, or XOR operator. All these you can't apply on the big integers, because at times you might be also having decimal numbers. Okay, and you want to perform bitwise operators on them, and there also you'll be having some bitwise operators, but I'm not discussing bitwise operators in here because there'll be completely a special video in which is related to Java and bitwise. There will be exploring simple concepts like bitwise operators, and we'll start from scratch over there, and we'll go to pretty deep and complex things like bit masking, and like finding Fibonacci numbers, or improving your runtime of the program from big O of n to big O of log n, kind of using bitwise operators, and the beauty of XOR operator, how where you can use the XOR operator in not only like in simple operations like swapping two numbers without using a third variable. You can use XOR operator, but at times you need the XOR operator in pretty complex stuff too. So we'll be exploring each and everything related to bitwise operators, and the Java support for bitwise operators. So that will be a series completed to related to bits, and there will be like a video on Java and a special video on C++ too, because C++ is pretty cooperative when it comes to bitwise and bits and all, bit shifts and arithmetic shifts. So I'll be having a video on that too. Okay, so I won't be discussing the bitwise operators in here, but I will be discussing arithmetic and logical operators, like not the operators, the methods which are given as replacement instead of having the operators. Okay, cool. So what are the arithmetic operators? We have the sum. Like I told you, these are not static methods. You can't write big integer dot add and pass in two values to this as we did in the math class. Here we apply the add method on a big integer and we pass another big integer to it, and the sum of these will be given to us. Similarly, the subtraction of these, and this will be taken as the subtrahend, and this is the minuend. I think you know the difference. The first thing and the right thing are like the RHS of the minus, and these will be multiplied, these will be divided, and only the division output will be given to you. Okay, and in here only the modulus operator will give you, like this is pretty similar, like this is plus, this is minus, this is asterisk, this is this slash, and this is this percentage symbol. Like we use that for the modulus operator, which just returns the remainder of the division and not the quotient. Okay, and at times there is also a special method in arithmetic operations which gives divide and remainder. Okay, begint 1 dot divide and remainder of begin 2. What this does is it'll divide begin 1 with begin 2, and it'll take the output in two forms. The first form, the first output will be the output of this method divide, and the second output will be this thing. Okay, and an array will be returned to us. Okay, see that? Okay, not an array, but we'll be returning a string over there. Okay, and to precisely, so I'm sorry, not this. I think we'll be returning an array. Yeah, big integer array is written. You see the square brackets over there. Big integer array will be returned, and it's not a pretty good thing to directly print arrays to the console. That is why I've wrapped this whole thing with arrays.toString. Okay, so I think you know why I'm doing it here. I can't just do like big integer .toString, because .toString is a method that is confined to only some classes and not all of them. Okay, so I'll have to do arrays.toString and then pass the arrays in here. Since this will be an array, that will be the parameter to the toString method, and the string will be returned. Okay, okay, let me call the arithmetic operations thing. I'll be uncommenting all this. Okay. I'm using scanner for input. You can use pretty much anything, buffered input reader and file IO reader, anything. Let me run it. Okay, it takes in two parameter. Let me be simple, right? Big integers are possible too, but yeah, before discussing this, let me be clear. The most important thing, always while dealing with big integers, this is which I'm telling out from my personal experience. I think it is wiser to use strings while dealing with big integers. Like when you're instantiating them, you want strings in there. Okay, so if your methods are taking in parameters which will be sooner converted into big integers, like don't send them in as integers. Okay, like you don't need x and y as integers here, because if you read them as integers, you'll have to pass them as integers, and if you're passing them as integers, here you'll have to use integer dot toString, or string dot toString, and then pass a parameter to that as x, and that will be an overload to you. Why don't you just read it as a string and then send it? Because anyways it will be converted to a big integer, doesn't matter. Okay, and reading it as a string is wiser at times. There is another reason for that too, because if you're having like a 30-digit number, you obviously cannot store it in an integer data type. Like int x equals to scan dot next int you'll be taking, and if you want to read a 30-digit number, it isn't possible, but in a string it is possible, right? So always use strings while you're passing parameters, and you'll be sooner, like in the very first step of the function, you'll be converting them into big integers. And for functions related to them, like those, I advise you to use strings as parameters and read the input as strings only. Okay, so now let me run this. Enter any number. I'll be taking 1200. Like I know this is possible in ints too, but I want to just show you the operations in here and not the magnitude and how big the numbers will be, because anyways you can't calculate the arithmetic operator, the sums and products of all those big two numbers. So let me be clear. And you see that the sum is obviously 2300, the difference is 100. If I pass 1100 and 1200, this will be minus 100, and the product is this, which is 1320. 12 11s is 132, we know that. And the quotient is 1. Why? Because 1200 will be divided, like you know, right? This is simple quotient, and the remainder is this, and we get the array out too, the remainder and the quotient in the using the same method. Okay, so that is it with arithmetic operators. Then we have logical operators. See there, where are they? Yeah, this will be taking again two strings, and the OR operation will be done on them. I'm sorry, here this should be AND. Like you get the point, right? This is the NOT operator. NOT will be taking obviously a single parameter, and it will return the opposite of it. Okay, and AND NOT is like similar to NAND but not NAND. Okay, first it will apply AND, and then it will apply NOT on the whole output of the AND operator. Like wrapping AND operator's output using a NOT method is what is AND NOT. Okay, this is because the people who have created the big integer classes, they identify that this series of operations of doing an AND first and then converting them, getting the NOT out of it, is quite many programmers are using it many times, so that is why they have included it here. And we have an XOR too, like as I told you, this is the not, maybe this doesn't come under here, that will be going to bitwise operators because it doesn't a logical operator, but at times we can use it as a logical operator too, not only on bit operators. Okay, so these are the logical operators, similar to the arithmetic operators. Okay, we also have comparison operators like equals. What does this equals thing do? Let's check it out. What's the name? Comparison, not equals. Comparison operators, and I'm reading two strings and passing them to this. Okay, so let me run this. Again, the same numbers, 1200, 1100. Are they equal? No, they aren't. So the equals method returns, where is it? Come on, where are you going every time? Yeah, the equals method returns a boolean. You can see that here. Where is it? It returns a boolean, public boolean equals, and the compare to is similar to the signum function. Okay, similar to signum function and not the signum function. It takes in these parameters. If the object that we are referring to, like this keyword that we are referring to, is greater than the passed parameter, then it will return a positive 1. If it is less than that, it will return a negative 1. If they are equal, it will return a 0. Like I can show you simply. If I send the same parameters, it will return a 0. Like 2 and 2, it will return a 0. Okay, and if I take the first parameter as a smaller number, then it will return a -1. Okay, so that is it with. Let me delete this. Anyways, we won't be using it, right? Arithmetic is gone. Playground, sorry, playground, I won't be using it. Math, I'll get into it. Logical, I'm done with logical. And comparison too. Cool. So the famous math methods that we have been discussing about, right? Okay, so here comes the math class methods, which will be reading a single number. So I won't need two inputs in there. That's fine. So I'll be sending it to my static method, math class methods. So what are the math class methods that are involved inbuilt? Because since we cannot use the math class static methods in here, we have the square root, begin dot square root. It doesn't need any parameters. It will return the square root of this begin. This will return the absolute value of this begin, which we have seen in the first thing. Like it is a modulus operator. Then we can take the power, begin, and whatever we pass it to the power, that will be applied as a power to this. If we pass 3, it will give the cube. If I pass 2, it will give the square. Negation is like that copy sign thing, where we are using, if at all the second parameter is -1 or +1 every time, and we are having a number with an opposite sign to the second parameter in the as the first parameter, then that is what is negate. Okay, if I pass in a positive number, it will return the negative of that number, and if I pass in a negative number, it will return the positive of that number. Okay, so signum is pretty the same. +1 if it is a positive number, -1 if it's a negative number, and 0 if it is a negative 0. Okay, so let me run this. Enter any number 2. Okay, square root is 1, obviously, because this returns only the integer value of the square root, 1.414, and you won't be getting the complete number. And this is a drawback, obviously. Here we'll be using the method that we have discussed. I've deleted them, sorry. That remainder and quotient completely divide. What is it? Divide remainder, maybe that method is. Yeah, we will be using that. Okay, absolute value will be given like we passed in a positive 2, so obviously we will return a positive 2, and the square of 2 is 4, and the negation is -2, and the sign we are getting a 1 because it's a positive number. Okay, and if I pass in a negative number, okay, we won't get it. Why? Because square root of a negative number, that doesn't exist, right? We'll have to put in a check over there. We can use the try catch blocks, or we can just write a simple if statement. Okay, so I'll be deleting this too. And here comes the third section maybe of our I hate this. And again I'll have to read two parameters. I should habituate that thing of commenting numbers and not just deleting them when I don't need them, right? This can be pretty annoying at times. Okay, so get GCD. There is an inbuilt method for get. Why isn't it used? Okay, I'll have to print it. Obviously, I'm not only printing something in the method itself, but I'm also returning something out from that method. So this method will print two statements and return an integer, and we'll be printing that integer over here, and we'll be capturing that return value in here as a parameter to the println function, and we'll be printing it. So what is the benefit of using this GCD function? GCD, you know the formula, like for finding the GCD you'll have to know the LCM, and for finding the LCM you'll have to know the GCD, and obviously you'll have to know the two numbers too, right? Like this is what I was taught in maybe 4th or 5th grade, right? LCM into GCD of two numbers equals to x into y, right? Like as far as I remember, this is the formula. And to find LCM, we divide this product with GCD, and to find GCD, we divide this with this. And at times, we might not know LCM and what we'll be doing in those cases, right? There comes the inbuilt GCD method. Okay. By the way, in the math class methods, I have not discussed max and min because they're having they'll need two parameters, and in the math methods thing, I passed only one parameter. So these are the only math methods available that will be taking in two parameters. The first, this keyword and this, this begin to, the maximum of them will be returned in the max function, and the minimum of these will be returned in the minimum function. Okay. So let me run that first. Yeah. Enter any number. 10. Okay. Another number is 5. So obviously the maximum is 5 and the minimum is, maximum is 10 and minimum is 5. Okay. So what is the GCD of this number? What is the greatest common divisor of these numbers? Obviously the greatest common divisor of 5 and 10 is 5, because 5 divides both 5 and 10, right? So GCD won't be 1, because 1 divides every number. And what is the problem of this GCD method? What does this do? It will return a big integer, and you don't want to return a big integer. Or if you're printing it to the console here itself, then you can do it. But I wanted it to show you how to return numbers using big integers, right? You can pass a string directly, like you can return a string here, and you can directly use that string thing over here. Okay, and that will be pretty the same, but I wanted to return an integer. So what did I do? First, I got the big integer output of this GCD method. I've converted it into toString method, so the output is now a string, and for integer.parseInt, the parameter is a string, right? To parse an integer, we'll need a string and not directly a big integer. You cannot write integer.parseInt and the big integer in there. You'll need a string in there. That is why I've converted into a string. Okay. Or if at all your so integer.parseInt method converts strings to integers. If at all they're convertible, and raise an exception if they are having some characters in them. So if at all I want to return a string over here, then I don't need this. I don't need to wrap it with integer.parseInt, right? I can directly return the toString of it, and in here I can directly print it, and this will be the same. There won't be any change in them. Okay. So again the same parameters, 10 and 5. See that this is 5 is the GCD, direct GCD. However big your number be, you can directly use this. So what do you observe here? Big integers are not only used for big numbers kind of things, but you can also use them for general math methods, or quick methods like GCD, and the most important part that we'll be getting into, the prime numbers thing. Okay. There is also modular arithmetic involved in big integers. There are 3 methods for modular arithmetic, but modular arithmetic is such a beautiful concept. I'll be discussing it in a private video, another video, and that will be having many theorems involved in that video. I'll be showing you how to use modular arithmetic and modular operations modular exponentiation, in dynamic programming, and in square root decomposition, in Chinese remainder theorem, like in Euler's torsion function or Wilson's theorem. That will be a series, a mini series kind of, where you can do miracles using modular programming, right? Like by modular programming, I mean using this operator. Okay, this might seem funny to you, but it is really important while we are solving problems on competitive programming online judges. So yeah, so there are methods in BigInteger class which are using the modular arithmetic. There are 3 methods, but I won't be discussing them in this video because I want them to be separate. Okay. So the most important parts of the BigInteger and BigDecimal classes, GCD and prime related methods. I've shown you GCD, and what are these prime related methods? Prime related methods, like you don't need to write a function, okay? Like you don't need to write a function to check if it is a prime. How do you write a function? You take in a number, you take in from 2, you write a for loop or a while loop, whatever be it. You write a loop from 2 to the square root of the past integer, and between all those you check if they are divisible by 2 or not, and if it is divisible by 2 then it isn't, and if it isn't divisible by 2 then it is a prime, and you return a boolean, and it's quite messy. Like it is an overhead, it's an overhead of a function. You'll have to write a separate function for that, right? And you don't need to do that if you're using big integers. There is directly let me get that cuff out of this. No, I don't need that. What are the methods remaining? Prime operations, and I think I'll need only one. Okay, this time I'll be commenting these. Yes, there you go. What's wrong? Okay, needs an int. Yeah, I'll show you what's wrong in here. Okay, I'll read it as an integer at all. Like I told you, use strings, right? Read in a string and pass a string, and because you'll be converting that string directly, you can directly do it like big integer of, you can pass that string and it will be simple. But if at all you don't want to do that, if you're strict to yourself and you want to use integers only, you want to take input as integers only, there comes the problem. What is it returning? It isn't returning anything. Yeah, that is why. That's the problem. Okay. Yeah, I'm sorry for the delay. Yeah, so BigInteger demo dot prime operations. Prime operations is my method. It is taking an integer. Okay, am reading an integer this time, and I'm passing it to this because it is expecting an integer parameter over here. And if it isn't a string, you cannot just pass it as x. Okay, you'll have to convert it into a string, and for converting a string to an integer, you use integer dot parseInt, and the parameter will be a string. And to convert an integer to a string, we use string dot value of, and whatever you pass in here, that will be converted to a string. Okay, so I'm passing a number that will be converted to a string, and that string will be used in the BigInteger constructor, and it will create a big integer for me. Okay, cool. Now, is it a prime? How do you find it? In general, you write a function and you pass it to that, and you get a boolean, and you do that, right? But you don't need to do it here. You just use the inbuilt function is probable prime, and you pass a certainty. Like this is like the probability, okay? Because this is like a probability related function, right? Is probable prime. Is it a probable prime? Is it probably a prime? Then we pass a certainty, how sure we want the function to be, and because I want it to be very specific about how is it a prime or not, I'm setting a full thing. Like most of the cases, 99% of the cases, you'll be passing 1 as a parameter to this function only. And if at all you want a false value out of this number, then you pass in a 0, because obviously then the probability is 0, and if it is a prime, it will return false, and if it isn't a prime, it will return true. Okay, that is opposite. It can do both of them. Like pretty cool, right? So I can use is probable prime, and what it will return is a boolean value, I think. Yes, a boolean value it is returning. By the way, intellij-idea is an IDE, so if I hover over the methods in there, I'll be getting a mini kind of a documentation kind of thing. And what is the return value? Is it a public or a private or protected member, or what package and what class does that come under, and how many parameters should be passed, and what is the name, and everything comes out. Okay, yeah. So this just gives it Boolean value, and at times you want to find a range of prime numbers, and for that what do? You keep printing the prime numbers if they are prime. You use the isItPrime function, the your own implementation of the isPrime function, and you pass it as a parameter. And if it is a prime number, then you print it. And if it isn't a parameter, if it isn't a prime number, you skip that number, right? In a loop, in a range. Like if you want to print the first 10 prime numbers or so, then you don't need to do that too. You have the what is the next probable prime number. Okay, you take a big integer that may be a prime number or that might not be a prime number, that doesn't matter. Okay, what this will do is it will take this number and it will find the next probable prime number. Like if I pass in 9 maybe, now what is the next probable prime number of 9? 10 isn't a prime number, 11 is a prime number, and we get 11 as an output. Okay, so let me demonstrate prime numbers functions in the big integer class. So I'll be passing in 9 and 11 is the next prime. And is 9 a prime? No, because 3 is a factor to it. And yeah, so that is it with GCD and Prime. I've also written the mod and mod inverse and mod power numbers, but I won't be discussing here. There'll be a special video about these. Okay, so how far did we go? Cool, we are done with 75% of the video. What is it with this problem? Like, I wanted to show you that what kind of problems are there on the competitive programming things, because I just don't want this to be raw, and you can read the documentation if you want to. I don't need to make a video, right? Let me solve a problem and that will show you. And before doing that, sorry, not this. Before doing that, let me also show you something really interesting. Like, let me copy this. There are some constants in big integer class. Okay, like which you don't need to use a new keyword, and you can directly pass them. Those are 0, 1, 10 and 2. Okay, if you pass in a 0, this big variable will be having a value of 0. Like, you don't need to do that thing using a string, right? And he introduce a new keyword over here. This creates an object. This will give you a memory allocation for this big variable, and it will be having this 0 as the value of it. And you can perform operations on this, like is probable prime, or next probable prime. All these can be applied on this because this is an object. And this is where the basic concept like wrapper classes comes in. If you don't want any methods, if you are not using any methods of that class, you just use the primitive data type, right? Int x equals to 5, and you cannot be like int dot toString and all of those. Those aren't possible, right? So if you want to do that, then you'll have to use the same int. You'll have to create an object out of that integer, right? Int x equals to new integer, because wrapper classes will have methods in them, and though you'll be using numbers in there, like though you're just needing an integer, you don't want to use a primitive integer, and you rather want to create an object out of that wrapper class, because you want some methods. You want to explore the methods inbuilt in the integer class, right? You have many methods in the integer class, you want to explore them. Okay, so that is where this comes in. And you'll be using the wrapper classes more if you're into containers and the collections framework of Java, which are like the inbuilt data structures in Java. You don't need to implement your own data structures. You have the stack, queue, and linked list, and everything is pre-implemented. You can just use them as you are using arrays or as you are using strings. It is that simple. Okay, there you'll have to use wrapper classes. Okay, so why am I talking all this, right? The benefit of creating an object out of the big integer class is you can apply methods on that, like all the is probably the modulus functions, or all the methods that I've discussed till now, the arithmetic, the add function, or the add method, or the logical methods, or power method, all can be applied on that using the big integer objects. But if I don't want that to happen, like I don't need that to happen, right? Shit, why am I doing this? Like, now this is not object, because we are not using the constructor and we are not passing in the new keyword and there is no memory allocation taking place. This is like a general int x equals to 5 kind of primitive kind of thing. Okay, so big is a big integer data type, but it is having a value of 0, and if you want it a value of 1, you pass 1, and if you want a value of 2, you pass 2. Okay, and at 10 you get 10. Okay, it is that simple. And unfortunately only these are there, and obviously you won't be having a constant for each of the numbers, right? These four are the most popularly used numbers like constant, so they have included those four as constant in there. And you cannot apply any methods on that big variable because that isn't an object, and if until and unless there is an object of the big integer class, you cannot apply methods of it because these aren't static methods. That is what I've been telling, right? So a lot of basic Java we've talked till now, so let's get into the programming of an online problem. So the problem that I'll be discussing is, yeah, by the way, this is the projecteuler.net website. In the archive section, you'll be having many problems. That keeps on going as you increase the problem number, the complexity keeps on increasing. It will be having many complex big integer kind of related numbers. See like 2 power 1000. Who deals with such numbers in normal programming, right? No one does that. And this is where big integers come in. This is where you use big integers. So let me solve this problem. 2 power 15 is this, and the sum of all these numbers is 26. What he is asking us to do is find 2 power 1000, and that will be like a 30 to 40 digits long number, and we'll have to find the sum of all those numbers. Okay, all the digits of that number. So how do you do that? Sum of the digits of a number is a pretty simple program that you do in the first sophomore year of your college, right? In the basic C programming course of your CS01 or whatever you have in your college. I think Indian guys should be knowing this. So let me go to Project Euler class. So what it is having here is, in the main method, I'm creating a big integer of value 2 because it is asking me to the power of 2 power 1000, and I can use the direct method of n dot power because n is the big integer. Begin dot power is a method that I've been discussing about. I cannot use a math method here, the math class, because big integers are not supported as parameters or as return types in math class static methods. That is why we are having separate methods in big integer. So to the power function I'm passing 1000. So I'm not storing it in a separate variable, since that will also be a big integer. I'm storing it in n only. So the initial value is 2, and now the value is 2 power 1000. So first, let me not calculate the sum digits. By this method returns the sum of the digits. Let me just print it. Okay, you see that this is 2 power 1000, and you cannot do this without big integer, right? Yeah. So okay, what did I do? Yeah, what I'm doing here is I'm calculate digits, expect a string. So I'm passing the big. This is a big integer, right? I cannot pass a big integer. I'll have to convert it to a string. So I'm using the toString method. Then the operation comes here, and I'm initializing it to 0 because I may take it too long, because that doesn't matter because we are just finding the sum of the numbers, and we are not having any number as big as 2 power 1000. So what is it doing? So the problem is I'm using an enhanced for loop over here. Like we can also use that for int I equals to 0, that naive for loop, but I'm using an enhanced, the new feature of Java. Like for I'm converting the string into a character array. We are having this in the string API, 2-char array. We'll convert it into a character array. So it will be an array of all those digits. So in each digit, like for every x, like every character x in that array, like this is what we do. And this enhanced for loop only applies to arrays and no other data type. And like we can also use it in the collections data like type, like array list and hash map. You can do there too, but as of now, since we are not talking about that, like what I want to make a point is we cannot use char x in string s. Okay, like this is only applicable on arrays. So that is why I've converted into a character array. And for every character in that array, what I'm doing it is I'm finding the int value of it, and I am appending it to my sum variable, which was initially initialized to 0. Okay, so this is a character. I cannot just do sum plus equals to 0, char x, right? The most problematic part about this is, let me comment this and show you. Sorry, sum plus equals to x, and this is valid because characters, this is a character data type and this is an int data type. You might be wondering how is this even possible. This is even possible in systems programming languages like C, C++, and in also Java, because there will be an implicit conversion going on in there, and your output will be in vain. It will be wrong. So don't trust this. If your ID, this is the drawback of using IDs, by the way. If you're using IDA, you'll be getting habituated to having that red line under your errors, and you can easily navigate to them and find the errors. But if you're not using it, and if you're using text editor, nowadays text editors are also having syntax highlighting and error highlighting, but if at all they are not, you will be developing a really great grip over the syntax. Okay, so but here this won't be underlined because implicit type conversion is going on, and the sum variable will be like the ASCII value of that number and not the number itself. For example, the character, for example, the first digit of this 2 power 1000 may be 3, for example. I don't know if it is. Then the ASCII value of 3 will be appended to sum, but not 3. Okay, so don't trust this. That isn't true. Now, what I'm doing is I'm converting that character to integer, and there is no character to integer conversion in Java. All you can do is convert a string to integer. So that is why what I'm doing is character dot to string of that string. So what will this do? It will convert my character into a single character containing string. Like it will convert 2 into 2. Okay, you see the quotes difference there. So as I've told you, integer.parseInt accepts a string as a parameter, so I can pass that 2, and now that will be an integer, and that integer will be appended to sum, right? Cool. Now let me run this. The answer is 1366. Like all the numbers that you have seen there, the sum of all that is 1366, and that's the answer. Okay, I've submitted this already. That is why I'm getting an answer and completed on this. That is why it's showing me that way. See, this is Project Euler, Project Archives, and you can find these largest prime factor, and you can submit the answer. There is no online editor over here. You cannot code in here. It is not like HackerRank or SPOJ or CodeChef, that kind of. You code it in your development environment and you just paste the answer of here. That is why most of the problems are related to math, and you see how big the numbers are. So if you want to practice with big kind of numbers and you want to obviously big numbers will take more time complexity, right? They'll be having very you want to optimize your code as much as you can. So this will improve your, point number one, it will improve your math skills, and second thing, it will also make you habituated to dealing with big integer type of numbers, and the third most important thing is it will also let you know how to upsolve and shorten the code, or include simpler algorithms, and reduce your time and space complexities, because they are making your code slow. Okay, and you are not getting that huge output out of your code, and you're getting an error out of it. So that is where those skills will be included in here if you solve on Project Euler. It is a pretty good website, so I want you to explore this, and there are good problems on SPOJ too. Like, let me go there. SPOJ is a Spear Online Jet. It is an online jet for competitive programming. In here too, there are very good problems. Okay, so yeah, so that is it for this video, guys. I think so. I'll be back with a video again. So signing off. Thank you.